our next example, we are going to solve a problem that involves either maximizing or minimizing a quadratic function. So here are 5 steps to use when you have a problem like that. So on this problem, example 4, we have 120 feet of fencing that's going to enclose a rectangular region. We need to find the dimensions of the rectangle that's going to maximize the enclosed area and then calculate that maximum area. So step 1, you have to decide what's going to be maximized or minimized, and it's area that we're going to be maximizing. Step 2, express the quantity as a function in just one variable. We're going to maximize the area of a rectangle, and to find the area of a rectangle, it's one side times the other, so we're going to use the formula A equals x times y. Now we have 120 feet of fencing, so the perimeter of the rectangle is 120. So 2 times x plus 2 times y equals 120. That means 2 lengths plus 2 widths equals 120. Now we're going to take 2x plus 2y equals 120 and solve that for y. So when you subtract 2x from both sides, then you'll have 2y equals 120 minus 2x. And then when you divide each term by 2, because remember we want to isolate the y, we'll end up with y equals 60 minus x. So next we're going to substitute what y equals, the 60 minus x, into a equals x times y. So that's really can be rewritten as a equals x times, now y is equal to 60 minus x. Or we could also write that as a equals 60x minus x squared. Okay, step 3 is to write the function in the form f of x equals ax squared plus bx plus c. So in this case, that would be f of x equals negative x squared plus 60x. Step 4 is to calculate the opposite of b over 2 times a. X equals the opposite of b over 2 times a. So that's going to equal, b is 60, so the opposite of b is negative 60 over 2 times a. A is negative 1, so 2 times negative 1. And negative 60 over negative 2 equals positive 30. Now remember from a previous example, x equals the opposite of b over 2 times a is the x-coordinate of the vertex. So this is where the parabola makes the turn. So we can decide if this is at a maximum or at a minimum. Well, since a is negative 1, so less than 0, means the parabola opens downward, which means the vertex is at the maximum. So this means that the area, a of x, of the rectangle with a perimeter of 120 feet is at a maximum when one of the rectangle's dimensions, x, is 30 feet. Step 5, we're going to finally answer the question posed by the problem. You have 120 feet of fencing to enclose a rectangular region. Find the dimensions of the rectangle that's going to maximize the area and what's going to be the maximum area. The rectangle that gives the maximum square area has dimensions of, well, we got an x of 30 feet. Well, if the length is 30 feet, then the width also has to be 30 feet, because 2 lengths plus 2 widths, each are 30, would give you the 120 feet of fencing. So the rectangle is a 30 by 30. Now to come up with the maximum area, a of x equals negative x squared plus 60x, so that equals negative 30 squared plus 60 times 30. So that's negative 900 plus 1800, which means the maximum area, of course, yes, I know, 30 times 30. You could have gotten it that way too. It's 900 square feet.